Hello guys, welcome to the section of floating point numbers. At the beginning of the previous section, we said that there are two main categories of numeric data types in C#, which are integral numbers and floating point numbers. In that section, we covered all types of integral numbers. And now, in this section, it's time to talk about floating point numbers in C#, which are used to represent real numbers with fractional parts, such as 3.14 or pi number. Alright, let's take a look at the data types diagram and show you where the floating point numbers are located. Floating point numbers, like integral numbers, are simple types, and C# provides several types for storing floating point numbers, such as float, double, and decimal. Each one of these types has its size, approximate range, and precision. Okay, now let's talk about them one by one. The first one is float type. This type represents a single precision floating point number, and it's used to store decimal numbers with a smaller range and less precision than the double type. To declare a variable of float type, we can use this syntax. Note that the f at the end of the value is required to indicate that it's a float number. So, if we leave off the f, the value will be interpreted as a double and the compiler complaining to us. Alright, the next type is double type. In C#, double type represents a double precision floating point number. We use this type to store decimal values with a higher degree of precision and a wider range of values than the float type. And you should know that any literal decimal value without a suffix is treated as double. Of course, we can use the D suffix for double literal values, but it's not necessary. Okay, the last one is decimal type. This type has a much higher precision compared to the float and double types, and because of that, the amount of memory occupied by this type is high. For example, this type is useful for financial and monetary calculations, where precision is critical. Like the float type, decimal type also required a suffix. So, to indicate that the literal value is a decimal, we have to use M suffix. Okay, let's jump into VS Code and show you some examples. First, let's declare a variable of float type. So, we go for float myFloat equals 10.2f. Now, let's display it in the terminal. Save the file and try it out. Okay, as you can see, we have a decimal value in the terminal. Now, let's declare two variables for double and decimal types. Let's display them in the terminal and see the result. Save everything up and try it out. As you can see, each of these types displays the same result. But as we mentioned, the main difference between these types is their precision. For example, the precision of float type is approximately 6 to 9 digits. For double type, it's approximately 15 to 17 digits. And for decimal type is 28 or 29 digits. So, based on what we said, let's assign the pi number to each of these types and see the precision of them. Okay, let's put the pi number here and assign it to each of these variables as a literal value. And let's add the f suffix for the float variable and the m suffix for decimal. Also, let's add the d suffix for the double variable, but as we said, it's optional. Save the file and let's test it out. As you can see, the precision of each of these types is different. For example, the result of fellow type has 7 fractional parts, because this type has a precision of approximately 6 to 9 digits. Also, based on double and decimal precisions, we have 15 fractional parts for double type and 28 fractional parts for decimal type. Okay, done. We'll see you again in the next lecture.